Good morning, everyone. I am Swapnil Dangrikar. I am from Guinness World Records. I, with my colleague Rishi Nath, we are here to see if you are able to successfully set a new Guinness World Records for the largest space exploration lesson. Now, all of you students here, I know you've been studying here for some, but with a show of hands, can you just tell us if you're ready to start with this record? Just show your hand if you're ready to start. Okay, I think all of you are ready. Great. So this is going to be a lesson like you have in your normal school lessons. You have to stay attentive for the duration of the lesson. It would be a little over 30 minutes, but anybody who needs to go out during the lesson will not be counted as a successful participant.
How do we study or explore space? Of course, you would say ideally you would like to go out there and explore space, but as you know, that is not that easy. We now have, of course, space missions that do go out, but they go out as far as to some of the planets in our solar system, not beyond that. So if you want to explore the entire realm of space, then astronomy is the best way to do that. Okay? So now let's try to understand a bit about astronomy. It is the oldest science. So all the time from when mankind settled down, as had agriculture and was able to start looking up and wondering what is up there in the heavens, in space. And so of course at that time we only had our naked eyes by which we could see the different objects, whether they are planets, stars, and so on. And that is what was the source of getting the information about space. And then it was man's mind ability to think and understand and deduce from those observations that led to our initial understanding of space. And it is to be noted, as you saw a bit in the introductory video that we had a short while ago, that there was significant development in astronomy in ancient India itself. And it's worth spending just a little bit of time to understand the rich tradition of astronomy and study of space that we have had in India. The roots of this can be traced all the way back to the Indus Valley civilization, and even in the Vedas there is significant mention of astronomical studies and discoveries and inferences. And Indian astronomy really reached major heights during the 5th and 6th century with the work of eminent scholars like Aryabhat, and then others who followed like Brahmagupta, Varamira, Bhaskara 1 and Bhaskara 2, and there were several fundamental inferences about the universe that was arrived at by astronomers. And I just show one example, the great scientist Aryabhat, who is attributed to have deduced these various things, that A, that the earth is round, B, that it rotates on its own axis, and C, that it revolves around the sun. So, to start with, you should keep this simple picture in mind. You all watch TV using your satellite TV dish, or you will have seen one, right? So, in principle, a basic radio telescope is very similar to your satellite dish system. What does it do? It receives radio waves from some part of the object. In your satellite dish, you're receiving it from a satellite that we have put up there, and it takes the radio waves, brings them to a focus on the dish, from where the waves are converted into an electrical signal, a voltage, and that signal is then amplified and then brought and further amplified and processed in order to give the final signal. In the case of your satellite dish, that final signal is the picture and the sound for any channel that you select on the TV, and that comes on your TV screen. In the case of the study of the universe, these signals are of different kind, plus about the details of the object that we are studying. Now, observatory, which is our own giant meter wave radio telescope located in India, and so that is the kit that you have, which you will be assembling, is one single antenna model of this array of antennas, actually 45 meters in diameter. And so the GMRT was conceived, our founding Professor Govind Guru, who founded the Radio Astronomy Group and the National Center for Radio Astrophysics, and it is under his leadership that this group, and it is operational since 2002 as an international facility which can be used by astronomers from anywhere in the world to carry out studies of outer space. And recently, in 2018, we completed a major upgrade. We improved the capability of the telescope by improving the electronics and the ability to observe over the range of frequencies, and making it a much more powerful and versatile radio observatory. So let us look a little bit. So if you go and ask Google to show you GMRT, Google will show you pictures like this. So this is a picture of the central part of the GMRT array. So there is a still 1 kilometer by 1 kilometer region where about 12 of 30 antennas are located, and you can, this is a zoomed in view where some of the nearby antennas, you can see them here, and this is a view of the central observatory where signals from all the antennas are brought. We use optical fiber to carry the signals from the individual antennas to the central building, and all the processing of the signals happen here, and the whole observatory array is controlled from the location. Waves into electrical voltage and then amplify them, because as we said, they are very faint, very weak signals. Amplify them by adding as little noise as possible, and then that amplified signal is brought down. So in order to reach to the top, if you have to change anything or do some work, you need a big crane like this. So this crane needs to go up to a height of 32 meters to reach the top over there. Okay, so you have a very simple scaled model of this antenna to be built later today. And when you build a big observatory like the GMRT, there are many aspects of engineering that go into such a thing.
Of course, this is not a working dish antenna. This is just a replica of GMRT dish antenna. So let us start and we will see how to make this GMRT dish antenna. So in this box, what all you will find? You will find a leaflet about NCRA and your career in radio astronomy, a leaflet explaining how to make this GMRT dish antenna, then some material to make this antenna of acrylic white color to paint this dish. Then we have speakers, and finally we have such two sheets, MDF pre-punched sheet, to make this dish antenna. You have to be very careful while removing these small parts. They are pre-punched and locked in this sheet. So you have to be very careful while removing these parts. So how to remove these parts? Let me show you by removing this big disc. So you will find some lock there. So you have to use your fingers and press with your nail so that this portion you can take out like this. Suppose this portion is out, then you can take out this ring very easily without breaking it. So of course this is a big ring. There are very small parts on this as well. So I will just show you how to remove one part. So just press it from one side and you can take it out like this. So this is how you can take different parts. Let me show you one more small part. You have to press from one side. So when you are pressing from one side, and so if I am pressing from back side, I am using my finger to press it on opposite side. So this is how you can.
This is really amazing, and when I'm getting this view from the top, I don't have any words to express the feeling which I'm able to have it in my mind. Together and assembling a radio telescope model. Thank you very much for your help. Thank you very much for your hard work.
So we are here with the official announcement for the record attempt that you all participated in. This was a lesson for space exploration which was never done before. We had set a minimum requirement of 250 successful participants. School children, do you know if you've broken the record? Do you think you've broken the record? We can't hear you here. So, with 1,002 successful participants, this is a new Guinness World Records, the third in a row. Congratulations to all of you.